Hi, this is Coach Dorf again. Now we're going to look at another homework problem from section 5.3. In this problem, we have g of x equals the integral from 0 to x of f of t, where f is the function whose graph is shown in red. Now this may look like the previous problem we've done, but it's somewhat different. In the previous problem, we asked certain questions. In this one, we're asking different questions. So the types of questions we're asking are different, although the function g is similar. All right, so how do we start here? Well, let's review first, what is g? So g of x equals the area, so under the curve y equals f of t, above the t-axis, and I'm going to use t-axis because my curve over here, the horizontal axis is t here, and between x equals 0 and some value of x, like that. So let's look at an example. First, I'm going to draw again my curve here. So first it goes up and then comes back down, down, up, and then like this. All right, I'm going to call this area A1. So if I just look at, as an example, what is g of 4? G of 4 is the integral from 0 to 4 f of t dt, and that equals that area A1. So in part A now, we're supposed to find local max and min, where the x values are that this occurs. All right, so in general, when does a local max or min occur? Well, if I have a function that's increasing and then decreasing, that's when I have a local max. So the function f is increasing here, and then it's decreasing. When does that happen in this particular problem? So in this problem, my function g is increasing as long as f, the red curve, is above the horizontal or the t-axis, and g is decreasing when f, the red curve, is below the t-axis, right? Why is that? Well, when the red curve is above the t-axis, that means my area is positive, area under the curve, because it's above the t-axis. So I'm adding more area. As soon as the red line goes below the t-axis, my area, I start subtracting that area off, all right? So in this problem then, here, this occurs when x equals 4 and x equals 12. All right, when x equals 4, the red curve is going from above the t-axis to below the t-axis. And at 12, it's also going from above the t-axis to below the t-axis. Again, why does that give me a local max? Because, for example, at x equals 4, the red line is above the t-axis, so I'm adding positive area. And when it's after 4, then I'm going to be subtracting that positive area after 4 because it's below the axis. All right, so this occurs, so we have a local max occurs at x equal 4 and 12. How about local mins? So when does a local min happen? Well, that looks like this for any curve. That's a local min there. And this means that f is going, for any function, it's going from decreasing to increasing. If it's going from increasing to decreasing, from decreasing to increasing, then it's going to have a local min. And in this problem, g is decreasing, as we said before, when f is below the t-axis, and g is increasing when f is above the t-axis. So this occurs in this problem at x equals 8. So that's when I have a local min. All right, part B says, where is there an absolute max? All right, so I have two local maxes, x equals 4 and x equals 12. So one of these is going to be my absolute max, and the one that will be the absolute will have the greater value. So I need to say which is larger, g of 4 or g of 12. G of 4 represents the area under the curve, and as does g of 12. So let's draw the curve again. And if I call this area A1, this area A2, and this area A3. Now, if you look at the original graph here, so let's see, so g of 4, again, is going to be the integral from 0 to 4 of f of t dt, and that's going to equal area A1. And if I look at g of 12, It's going to equal the integral from 0 to 12 of f of t dt. And that's going to equal a1 minus a2 plus a3. Yeah, let me rewrite this here just as just a1. We know that that's area, but it's right like that way. I think it'll be easier to see. Now, it's not so clear on this diagram of the red curve here that I drew for part B. But if I go back to the very beginning problem, I can see that if I rewrite these things, there's A1, there's A2, and there's A3, that A1 is larger than A2, which is larger than A3. They're getting smaller as I go. So I'm going to use that fact here. So I know that A3 is less than A2. Now, some people will say, well, A2 is negative. Well, we're thinking just the area there is a positive number. And when we do the integral, we subtract the A2 because it's below the t-axis. That's why we have for G12 minus A2, A1 minus A2 plus A3. So the total area for A3 is less than A2. Again, it's not so clear on the graph I drew here on the screen right now, but if you go to the very beginning, the original graph, you can see that A3 is less than A2. All right, so that means then that if I subtract A2 from both sides, just do that this way. So subtract A2 from both sides here, and I'm going to get minus A2 plus A3 is less than 0. And now if I add A1 to both sides, I get A1 minus A2 plus A3 is less than A1. Well, what is A1 minus A2 plus A3? That's G of 12. And what's A1? That's G of 4. So this is saying G12 is less than G4. And that should make sense if I look at the graph, because I've got A1 gives me the most area. Then I'm going to subtract off a little bit of area for A2 because it's below the t-axis. And I'm going to add some A3. So the original A1 is going to be larger than if I do A1 minus A2 plus A3. So what does this all tell me then? This gives me then that absolute max occurs at x equals 4, since G of 4 is greater than G of 12. All right, that's B. Part C, interval concave down. So we have to think about this for a second. So I want to find out the interval of G, intervals for which the function G is concave down. So when is G concave down, or any function concave down? Well, we go back to the second derivative test. Second derivative, concave down is the frowny face, so I have negative. So that means G, the second derivative of G is less than 0. That's when I have G is concave down. Well, now let's compare this now to F. What is G? G is the integral from 0 to x of f of t dt. So now that's the G. I want to get the second derivative. So what's the first derivative? First derivative would be to take d dx of the integral from 0 to x of f of t dt. What is the derivative of the integral of f of t dt? That is just f of x. And that comes because of the fundamental theorem of calculus. So now I've got the first derivative, I need to get the second derivative. So now I'm going to take the second derivative. Well, the first derivative of g is f, so the second derivative of g is the derivative of f, or f prime. And what does the derivative of f mean in terms of my red curve? Well, that means that represents the slope of the tangent line to y equals ft, which is the red curve. So when we want g double prime to be less than 0, which means we want f prime to be less than 0. All right, so that's when the slope of the tangent line is negative. Or in other words, we could also think of this is f prime is less than 0 implies f is decreasing. So the original function is decreasing. So I go back to my original curve here. Where is the red curve decreasing? Well, I look at this from 2 to 6. The curve here is f is decreasing. It's also decreasing from 10 to 13. It's also f is decreasing. So my answer here is that f is decreasing on the intervals from 2 to 6 and 10 to 13. All right. So again, f is decreasing on that interval, which means the first derivative of f is less than 0. And the first derivative of f equals the second derivative of g. And so that means the second derivative of g is less than 0, which means that g is concave down. So g is concave down from 2 to 6 and 10 to 13. All right, last part is part D, which is to sketch the graph of g. So we'll make it, here we go, 2, 4, 6, 8, 10, 12, 14. And I'm going to use blue here. So let's see, what is g of 0? That's the integral from 0 to 0 of f of t dt. Well, anytime I have an integral from its 0 to 0 or from this number to the same number, that's always equal to 0. So my initial point here is 0. G of 0 is 0. Then what happens to g as I go from x equaling 0 to 4? Well, if I go back to my original graph here, the area under the red curve is increasing. Area keeps increasing. It's above the x-axis all the way until I get to 4. So that means that g is increasing all the way up to 4. Rewrite this a little bit. I know I'm going to have an absolute max. We're going to have a local max at x equals 4, and it's also going to be an absolute max. Now, what happens after I leave 4? Well, in this case, I go below, the red line goes below the x-axis, the red curve. So I'm decreasing the amount of area. So my function g should be decreasing all the way from x equals 4 to x equals 8. But the amount it's decreasing, the amount of area below the t-axis is less than the amount of area above the t-axis. So the amount of area that A1 from 0 to 4 is greater than the amount of area A2 that's below the t-axis. So I don't go all the way back down here. I'm just going to go down a little bit, this, and then I have this. And remember, I believe we had that at x equals 8, we had a minimum, so a local minimum. And now from 8 to 10, the red curve is above the x-axis, so I'm adding area. So I'm going to keep going up, but not as much as I was before, because at 10, I have a local max, but not the absolute max, because the absolute max occurred at x equals 4. So let me redraw that. So local max. And now at 12, the original red curve goes below the x-axis. So I'm going to start losing area. So g is going to start decreasing and go down something like this. And that was going to happen. Can't quite get this to work. Something like that. All right. And does this match with all of my other aspects? G is supposed to, so this is my g of x curve. Is g concave down? From the previous part, in part C, we said it's concave down from 2 to 6. And that looks like about right. 2 to 6, concave down. All right, some problems right in here. Concave down here. And from 10 to 13, it's also concave down. We have absolute max, we have a local max, and we have a local min. So everything seems to work. All right, hope that helps you.